In today's lecture, we will do multiple choice questions based on the inclined plane. First question is, two frictionless inclined plane making an angle 30 degree and 60 degree with the vertical. So in first case, angle with the vertical is 30 degree, and in second case, angle with the vertical is 60 degree. The two blocks A and B are placed on the two planes as shown in the figure. What is the relative vertical acceleration of A with respect to B? If a mass body is placed on an inclined plane, then its weight acts downward and a normal reaction acts perpendicular to the plane. And the component of weight, that is the mg, are mg sine theta along the plane, this angle is theta, and the component perpendicular to the plane will be mg cos theta. This n get balanced with mg cos theta, and friction force is 0 because it is given that frictionless inclined plane. Therefore, net force on block will be equal to mg sine theta, and this will be equal to mass into acceleration. Therefore, acceleration in the block will be g sine theta. Now, in the question, it is asked that the vertical acceleration. So, if we calculate the acceleration component which is vertical, so g sine theta is the component along the plane, and we have to make its vertical component and horizontal component. Because angle of the inclined plane is theta, so angle with the horizontal is theta. That means component which is vertical, it will be g sine theta. This is the acceleration along the plane, and its component in vertical direction will be the sine component. So vertical component of acceleration equal to a, which is a g sine theta, and the sine theta, that is equal to g sine square theta. So relative acceleration of vertical component of block A and block B will be equal to g sine square. For block A, this theta is the 60 degree minus g sine square, and the angle of the inclined plane with the horizontal is 30 degree. So we can write it as g into 3 by 4 minus 1 by 4, that is equal to g by 2. And this component is along the vertical direction. So option D is the correct option. Second question is, the minimum force required to start pushing a body up a rough having the frictional coefficient mu inclined plane is F1, while the minimum force needed to prevent it from sliding down is F2. If the inclined plane makes an angle theta with the horizontal such that tan theta is equal to 2 mu, find the ratio F1 by F2. There are the two cases. The inclined plane is having the angle theta with the horizontal, and the block of say mass m is kept on this horizontal plane. In case 1, it is pushed up to move, while in case 2, it is pushed to stop from sliding. Let the force applied are F1 in first case as per given the question, and F2 in second case. Then the weight which acts downward has the horizontal component along the plane in downward direction, and it is mg sine theta which try to move the block downward. Similarly, in second case also, mg sine theta is working downward. In first case, the block is trying to move up, so there will be a frictional force, and this friction will be in downward direction and represented by small f. In second case, it is sliding, So in case of sliding, the friction force will act upward and it is suppose represented by small f in upward direction. In first case it is F1 and in second case it is F2. And this F and F1 are less than equal to Fms, maximum static friction force. Similarly, F2 is also less than equal to Fms. So in case 1, to move the body up on the inclined plane, the balance equation will be F1 equal to mg sin theta plus F1. And to make this F1 minimum, this F1 should be equal to Fms, maximum static friction force. So we can write it as mg sin theta plus, and static friction force is mu into normal, and component of mg perpendicular to the normal plane will be mg cos theta, and this get balanced by the normal reaction. So this F1 is Fms is mu n, and we can write it as mg sin theta plus mu into mg cos theta. In second case, balancing condition is F2 is equal to mg sin theta minus F2, that is equal to mg sin theta minus mu n, and again we can write it as mg sin theta minus mu into, and this n again equal to mg cos theta. As per question, we have to find the ratio F1 and F2, and taking the mg cos theta common from F1 and F2, we will have this is tan theta plus mu divided by mg cos theta tan theta minus mu. This mg cos theta get cancelled and tan theta is given 2 mu. So we will have 2 mu minus mu by 2 mu minus mu. This is plus. So we will have 3 mu by mu, and mu get cancelled and rest is 3. Hence option D is the correct option. Third question is, a block of mass m is pulled along a horizontal frictionless surface by a rope of mass small m. If the force P is applied at the free end of the rope, the force exerted by the rope on the block. If we make a diagram, this is the surface on which a block of mass m is kept, and it is pulled by a rope of mass small m with a force P. So we have to find the force exerted by the rope on the block. If we make a free body diagram of the mass block m and the rope is small m, force P is applied by the external agent on the rope, and there will be a tension in the string, and same is applied as per the Newton's third law on the block m, and the whole system is moving with the acceleration a. So we can write that P minus T equal to m into a. Similarly, T equal to m into a. So adding these two equations, number 1 and 2, we will have P equal to ma plus capital Ma. Here a is taken common, so it is m plus capital M. Hence, acceleration A will be equal to P by m plus small m. The force on the block, that is T. So T will be equal to m into A, and A is P by capital M by small m. Hence the option D is the correct option.